I'm here to talk to you today about what I'm calling islands of context and finding your organization's true north. I want to start out by saying how incredibly grateful I am to be here today with all of you. And it reminds me of this quote: "What you see and what you hear depends greatly on where you are standing. It also depends on what sort of person you are." It's transformative experiences like today that remind me that we each have our own unique perspective of the world. Our experiences, our upbringings, our values, and our privilege are all lenses through which we perceive our reality. And when we create technology that augments that perception, it too has a lens through which it sees our world. And it is that lens that determines what it can and cannot understand about our reality. Today, we are going to explore how human intelligence has shaped the development of artificial intelligence systems, from how our brains perceive information to the revolutionary frameworks that are transforming the ways in which organizations leverage AI. Our journey will reveal both the fundamental challenges as well as the exciting opportunities that lie just over the horizon. Our brains are phenomenal organs of both perception and meaning making. Think about the first time you fell in love or experienced profound grief, or the childlike wonder of discovering something new about the world. Whether you realized it or not, each one of these experiences fundamentally changed the way you perceived your reality from that moment forward. Our brains physically create new neurological pathways that change the framework of how we experience reality. And this emotional and embodied experience of being a human creates a deep contextual landscape that I believe AI will simply never be able to replicate. Each and every one of us is a unique kaleidoscope of thoughts, feelings, and experiences. And when we communicate with each other, we do so through a language that is built on layers of context, nuance, and social contracts. And when we communicate with each other, we do so with the goal in mind of helping the other person to see the world through our eyes. And as complex as that sounds, it is as natural and necessary as breathing for human beings. Throughout history, we've had many brilliant minds who have offered us additional lenses through which to see both information and intelligence. Claude Shannon is considered the father of information theory and taught us that information is the resolution of uncertainty. It was his mathematical theory of communication that led to our current day's understanding of both data transmission and compression. He also invented a flame-throwing trumpet. So unique. Shannon's approach in early information processing led him to create what we now know as the first artificial intelligence machine, a maze for his mechanical mouse Theseus to navigate autonomously. Through a magnet and a series of electromagnetic switches, not only was Theseus able to navigate the maze successfully, he could reproduce the route from memory. Just like his predecessor, Theseus first had to navigate the correct route, through trial and error. Rather than using a golden thread, though, this little guy uses a set of electromagnetic switches attached to binary choices: yes or no, on or off, 1 or 0. This reduction was powerful for computation and led to our current day binary code systems. It was Alan Turing who proposed the question, can machines think? This philosophical question launched the area of artificial intelligence into the sphere of human thought, questioning consciousness itself. He created what we call the Turing test. He surmised that if a machine was capable of having a conversation that was indistinguishable from that of a human being, it could potentially, in some meaningful way, be thinking. In this CAPTCHA, it's asking us to select images of bridges. This is a perfect example of a context that a human has no trouble with, but that machines continue to struggle with. This was no more evident than it was to Herbert Dreyfus, who saw through what we call the symbolic lens. He was a professor of philosophy at MIT. When in 1960, the MIT Artificial Intelligence Lab asked him to create a test to prove their hypothesis that they had created an AI model that was as smart as a human 4-year-old. Bert was happy to oblige. He came up with a story. Here is that story. It was Jack's birthday. Mary and Jane were going to Jack's house. Let's bring him a kite, said Mary. No, said Jane. He has already got one. He will make you take it back. When a 4-year-old child hears this story, they effortlessly understand all the key points of the story. Clearly, it's Jack's birthday, and Mary and Jane are going to Jack's house for his birthday party. The kite is clearly a gift, a birthday gift. He will make you take it back refers to returning it to the store from which she bought it. And that kites are something unique for humans where one is enough, unlike dollars and donuts, which will take as many as we can get. However, the AI model suffered tremendously with this story. It didn't understand social traditions like birthday parties and gift giving. It didn't understand retail behavior of store return policies. It had difficulty following the pronouns of one and it referring to the kite. And it also didn't know anything about object categorization, that sometimes one is enough and sometimes more is better. Herbert Dreyfus called this the common sense problem, the contextual frameworks that are required for a machine to understand the things that humans take for granted. This created an immense storage issue. An AI system would need vast databases of common sense knowledge to navigate even a simple narrative that a human could understand. And this was simply something they could not solve in 1960. Larry Page and Sergey Brin, the founders of Google, offered us the machine algorithmic organization lens, showing that if we structured the world's data, it could not only be universally accessible, but easy to use, fundamentally changing the way we find and interact with the world's knowledge. However, if I were to ask traditional search, like Google, a question that requires context, like, what other movies are the cast of The Big Lebowski in together? I'm a little bit of a fan. I don't know if you've caught that at this point. It would take my question and break it into a set of keywords. It would then return a list of results of pages that contain those keywords. This is because traditional search sees my question only through a single lens. It takes a set of disconnected keywords and it reviews a set of pages that contain those keywords without ever really understanding my question or the relationship between the actors. If I were to go to a site like IMDb, though, we could get a little bit closer to how a human would think about this same question, as a series of relationships. I would first be able to discover the main 4 actors in the cast. I could find out easily that John Turturro is in a hit show called Severance with Christopher Walken, and that he got his start in a movie called Quiz Show with Ralph Fiennes. I could discover that Steve Buscemi was in an independent film called Reservoir Dogs, and then made the really unfortunate movie of being in a movie with Adam Sandler. I know so many people like this movie. I hate it. We're just going to have to agree to disagree on this. We discovered that John Goodman was in a hit show called Roseanne, and then also made the unfortunate decision of making a live-action version of the Flintstones, a move I will never understand. If I dug a little deeper, I could probably discover that John Turturro and John Goodman were in a Coen Brothers movie called Oh Brother, Where Art Thou together, and that John Turturro and Steve Buscemi were in another Coen Brothers movie called Miller's Crossing. And if I dug really deep, I may be able to discover that Steve Buscemi and John Goodman were voice actors together on the Disney Pixar movie Monsters, Inc. But what I would never find out is that Jeff Bridges never appeared in another film with any of these other actors. Now, consider what happens when I ask the same question of a large language model. It takes my question and breaks it down into a set of individual tokens. Those tokens activate pathways through a vast neural network of interconnected information, just like how the human brain works. But unlike traditional search engines that match keywords, the LLM is able to navigate a web of interconnected associations and recognize patterns. If we look at the Big Lebowski question through this lens, a constellation of connections suddenly appear. We discover that John Goodman, John Turturro, and Steve Buscemi were all together in both Barton Fink and Hudsucker Proxy. We couldn't see any of these connections from a single vantage point. It is only when we expand our perception do they appear. It was the development of large language models that marked a fundamental shift in our approach when we embraced this critical insight that words derive their meaning from their relationship with other words, as well as the context within which they appear. Now, despite their power, as we all know, large language models have struggled with some critical flaws. It was in 2022 when ChatGPT released the first large language model with natural language processing capabilities, revolutionizing search, creating a conversational search modality that we had never had before. But it suffered greatly from hallucinations, and its black box nature made it difficult for people to verify the information they were given. Luckily, Perplexity came out shortly after with their large language model, which included citation abilities, which made it a little bit easier for users to verify the source of the data they were given. In 2023, Anthropic launched their large language model named Claude, after Claude Shannon. And it was focused on higher reliability rates, as well as lower instances of hallucinations. But it was in 2024 when OpenAI added hybrid search to ChatGPT that things really changed. It gave us the ability to connect pattern recognition through large language model training data with real-time web searches. This evolution from pure large language models to verifiable, reliable, and real-time data highlighted the immense potential in AI development. In fact, we have seen from survey data in early 2025 that Americans are adopting AI at record rates. 45% of Americans have used AI in the past 30 days. 36% report using AI to complete everyday tasks. And 18% have even said they've used AI to assist them in shopping. Just this week, ChatGPT announced the addition of shopping tiles, which will create the ability for people to shop directly from within the AI interface. So what does this mean for our organizations? As the Director of Technical Strategy at One North, I've had the unique privilege of working with my talented colleagues on several transformative projects where we're examining the ways in which artificial intelligence is shaping the digital landscape. We realized that in order to stay competitive, we needed to shift our perspective, adjusting to focus on information, not how we see it, but how artificial intelligence perceives it. Like many others, we had previously focused when it comes to our web content on search engine optimization, ensuring that our information was clear and accessible for those who sought it out. But what we discovered is that we needed to shift our perspective to encompass generative engine optimization as well, or GEO. This is about structuring our content effectively so that it is retrieved and represented by AI models in a way that matches our brand voice, our services, and our offerings accurately. We have discovered that this really isn't about replacing search engine optimization. In fact, our early experimentation has concluded that search engine optimization is how you are prioritized by the LLM's training data. However, if it doesn't have the information that the person is asking for, it then takes that query and does a live web search. And that's when GEO comes in, generative engine optimization. We are in the process of developing dual optimization strategies that will focus both on making our information impactful and visible across traditional search and conversational search. Currently, when a user asks a large language model like ChatGPT about our organization, One North, it first searches its training data. If it doesn't have the answer, it then does a web search, which can produce incomplete or sometimes incorrect answers. We are looking at two technical paths to generative engine optimization. The first path is focused on when users ask a question of AI that it doesn't have the answer to. It can then connect to our site through a model content protocol server and access an informationally structured file called an LLMs.txt. This assists AI in both ingesting and displaying an accurate representation of our brand and services. The second path is when we look at optimizing our sites for conversational search. Using that same MCP server, we can place our own AI model that is connected to our organization's knowledge base. Then ChatGPT, Perplexity, or Claude can have a conversation, AI to AI, to get the answer it needs. But this functionality also offers us the opportunity to place conversational search on our website so that our information is optimized, whether someone is visiting a third-party AI model or visiting the One North website. But there's a third lens that's emerging just over the horizon, one that will fundamentally transform who, or rather what, is traversing the web. AI agents like OpenAI's Operator are becoming autonomous actors, just like Theseus the mechanical mouse, that explore the web on your behalf. Today, a human visits OpenTable or Airbnb to make a reservation. Tomorrow, your personal AI agent will navigate the web to make dining reservations that meet your particular preferences or book hotel rooms that match your travel style, all without you ever seeing the website. For me, this was a fundamental shift in the way we think about optimization. I don't know about all of you, but I've spent the last decade trying to keep bots off of websites. And now we need to figure out ways to make websites optimized for those same bots. And honestly, having a personal AI agent sounds kind of amazing. But the truth is, both our personal lives and our organizations require so much more than simple travel itineraries or dining reservations. They're complex, messy, and interconnected, containing countless nuances and a myriad of dependencies. A single generalist AI model, no matter how advanced, cannot grasp all of the necessary connections and context needed to help us in these multifaceted domains. That's where agentic frameworks come in. We're building interconnected networks of specialized tools that work together, each handling different aspects of complex problems while communicating with one another. In the center is the orchestration agent. It is the conductor of the orchestra. It takes in your query, and it works with all the different components to coordinate a solution. Large language models serve as the reasoning core. They provide language understanding, problem solving, and decision making. Tools handle everything outside of what LLMs are capable of. They might be browsing the web or doing calculations or searching vector databases, and it includes multimodal tools that make images, video, and audio. APIs connect to external systems and have the ability to connect data sources within the agentic framework. It also gives us the ability to advance current infrastructure without replacing it. These augment the capabilities that we have in our current tech stacks rather than replacing them. And of course, memory. Both short-term and long-term memory give artificial intelligence the ability to create cohesive conversations and learn over time. This diagram illustrates not just a technical architecture, but a new way of thinking about artificial intelligence. At the center, we see the agent coordinating between different tools and planning methodologies. The future isn't about a single assistant doing everything. It's orchestrated intelligence with specialized agents collaborating on complex, real-world challenges. These components work together, addressing multifaceted tasks that would overwhelm any single system. Industry leaders, such as Microsoft's Chief Scientific Officer, Eric Horvitz, have increasingly shared our view that AI is good at pattern recognition, viewing large amounts of data, and automating repetitive tasks, where humans bring creativity, empathy, ethical judgment, and contextual understanding. As we build these agentic systems, it is the human lens that reminds us that our goal isn't to create isolated islands of artificial intelligence, but to build bridges that connect human and machine understanding that amplifies what each of us are extraordinary at. This collaborative perspective may ultimately prove to be the most important lens of all, one that sees AI not as a replacement for human intelligence, but a partner to it. We saw how traditional search stood in one place, while modern AI systems continually shift their perspective to be able to find meaning and connection. What appears as random, disconnected debris from one angle with a new perspective can reveal something that is both purposeful and cohesive. Over here, we have something from your perspective that may look like a pile of trash. However, through the right perspective, reveals a vessel capable of navigating uncharted waters. Thank you, Vanna. This is the transformative power of perspective. But this vessel cannot sail itself. It requires both AI and human hands on the wheel. AI excels at navigating across large open waters of vast amounts of information, while humans provide the critical compass of creativity, empathy, and context. Together, we navigate waters that neither of us could traverse alone. Thank you.